Teleportation, once relegated to science fiction, is now a topic of serious scientific exploration. Scientists are making strides in quantum teleportation. It's about transferring quantum information, the properties of particles, instantaneously. Quantum teleportation hinges on entanglement. Two particles share the same fate no matter the distance. Change one, and the other mirrors it instantly. This spooky action is the bedrock of quantum teleportation. Teleporting information holds incredible potential. Imagine ultra-secure communication networks, impossible to hack, or powerful quantum computers solving problems in seconds. We're still in early stages, but progress is astounding. Scientists have teleported photons across astonishing distances. The allure of teleportation extends far beyond its practical applications. It speaks to a deep-seated human desire to transcend our physical existence. We yearn to explore the cosmos and connect with loved ones instantly. Throughout history, humans have sought ways to overcome distance and time. From the wheel to supersonic aircraft, our quest for faster travel is relentless. Teleportation represents the holy grail of this pursuit. It promises a world where space and time bend to our will. The potential benefits are vast, but it also raises profound questions. We must consider the implications on identity, time, and free will. While the dream of stepping into a transporter and materializing on a distant planet might still be a ways off, the scientific community is cautiously optimistic. Breakthroughs in quantum teleportation, focused on information rather than matter, have opened new avenues of exploration. The challenges are formidable, requiring a concerted effort from brilliant minds across disciplines. Teleportation holds the promise of revolutionizing transportation, communication, medicine, and even enabling us to reach for the stars. The journey will be long and arduous, but with each breakthrough, we inch closer to a future where the impossible becomes possible. To grasp the concept of teleportation, we need to venture into the strange and wonderful world of quantum mechanics. This branch of physics governs the behavior of matter at the atomic and subatomic level, and it's about as far from our everyday experience as you can get. In the quantum realm, particles don't behave like tiny billiard balls. They're more like fuzzy waves existing in a superposition of states, meaning they can be in multiple places at once. One of the most mind-bending aspects of quantum mechanics is the idea that observation affects reality. Before we measure a particle's properties, like its position or momentum, it exists in a blurry state of potentiality. It's only when we observe it that the particle chooses a definite state. This fundamental uncertainty is not a limitation of our instruments, it's built into the very fabric of the universe. Another key concept in quantum mechanics is wave-particle duality. Light, for example, can behave both as a wave, spreading out like ripples in a pond, and as a particle called a photon, which carries a discrete amount of energy. This dual nature of matter and energy is one of the many mysteries that physicists are still trying to unravel. But perhaps the most intriguing phenomenon in the quantum world, at least for our exploration of teleportation, is entanglement. Imagine two particles, intrinsically linked no matter how far apart they may be. They're like two coins flipped at the same time, forever correlated. This is the essence of entanglement, a quantum connection that transcends distance. Measure one, and you instantly know the state of the other. This spooky action puzzled even Einstein. Experiments confirm entanglement is a fundamental aspect of our universe. It's the foundation for quantum technologies, including computing and teleportation. Quantum teleportation isn't about beaming Captain Kirk to a distant planet, at least not yet. It's about transferring quantum information, the properties of particles, from one location to another without physically moving the particle itself. Think of it like sending a blueprint of an object rather than the object itself. Here's how it works. Scientists start with two entangled particles, let's call them Alice and Bob. They separate Alice and Bob, sending one to a distant location. Next, they take a third particle, carrying the quantum information they want to teleport, and entangle it with Alice. This interaction creates a unique signature that instantly affects Bob, even though Bob hasn't directly interacted with the third particle. By carefully measuring the state of Alice and the third particle, scientists obtain a set of instructions that they can send to Bob's location. These instructions, sent through classical communication channels, act like a recipe, allowing Bob to recreate the exact quantum state of the third particle, effectively teleporting the information. While this process destroys the original quantum state of the third particle, it's faithfully recreated in Bob, preserving the information. It's like faxing a document. The original document remains, but an exact copy appears at the destination. Quantum teleportation has been experimentally demonstrated with photons, electrons, and even atoms, achieving teleportation over distances exceeding hundreds of kilometers. While teleporting quantum information is a remarkable feat, teleporting matter, like a human being, presents a whole new level of complexity. The human body is an intricate system of trillions of atoms. We'd need to scan and deconstruct every atom's quantum state, transfer that information, and reconstruct the person. The information required is staggering, beyond any existing computer system. Scanning a person's quantum state raises profound ethical questions. The energy required would be astronomical. A single misplaced atom could have catastrophic consequences. Despite these challenges, the scientific community is not giving up. Researchers are exploring wormholes as a potential solution. Imagine folding a piece of paper in half so that two distant points touch. Now imagine punching a hole through those points, creating a shortcut between them. That's a simplified analogy for a wormhole, a theoretical tunnel through space-time that could connect distant regions of the universe. Wormholes are predicted by Einstein's theory of general relativity, which describes gravity as the curvature of space-time caused by massive objects. According to this theory, it might be possible to create shortcuts through space-time by warping the fabric of the universe itself. While wormholes remain purely theoretical, some physicists believe they could provide a means for faster-than-light travel, or even time travel. By entering one end of a wormhole, a traveler could emerge from the other end at a distant location, potentially billions of light-years away, in a matter of moments. However, there are significant challenges associated with wormholes. They are thought to be incredibly unstable, prone to collapsing before anything could travel through them. Furthermore, creating and stabilizing a wormhole would require exotic matter with negative mass energy density, a substance that has never been observed. Despite these hurdles, the concept of wormholes continues to captivate scientists and science fiction enthusiasts alike. If we could harness the power of wormholes, it could revolutionize our understanding of the universe and open up possibilities beyond our wildest dreams. While the prospect of teleporting ourselves across vast distances might seem like pure science fiction, the scientific community is making remarkable strides in understanding the fundamental nature of space, time, and the very fabric of reality. The more we delve into the mysteries of the quantum world and the cosmos, the more we realize that the universe is far stranger and more wondrous than we ever imagined. The concept of teleportation, once relegated to the realm of fantasy, is now a topic of serious scientific inquiry. While we may not be beaming ourselves to distant planets anytime soon, the breakthroughs in quantum teleportation, coupled with our growing understanding of space-time, suggest that the impossible might not be so impossible after all. The pursuit of teleportation is not just about finding a faster way to travel, it's about pushing the boundaries of human knowledge and exploring the ultimate limits of what's possible. It's a testament to our insatiable curiosity, our desire to understand the universe and our place within it. And who knows, perhaps one day the line between science fiction and reality will blur, and the dream of teleportation will become a reality, transforming our world in ways we can only begin to imagine. While the idea of teleportation is incredibly exciting, there are some pretty big hurdles standing in the way. One of the biggest roadblocks is something called the no-cloning theorem. This principle of quantum mechanics states that you can't create an exact copy of an unknown quantum state. In other words, you can't just scan a particle and create a perfect duplicate without destroying the original. Then there's the issue of energy. Teleportation, even at the quantum level, requires a tremendous amount of energy. Think about converting an object into pure energy, beaming it across a distance, and then reassembling it perfectly on the other side. And let's not forget about the speed of light. According to Einstein's theory of relativity, nothing can travel faster than light. One of the biggest head-scratchers when it comes to teleportation is how to deal with the weird world of quantum mechanics. In the quantum realm, particles don't have definite properties until they're measured. This quantum fuzziness makes it incredibly difficult to pinpoint a particle's exact properties, let alone transfer them to another location. Then there's the issue of entanglement. While entanglement is essential for quantum teleportation, it's a very delicate phenomenon. Entangled particles are easily disturbed by their environment, which can break the entanglement and scramble the information being transferred. And let's not forget about the sheer number of particles involved in teleporting even a small object. Despite these challenges, scientists are making progress in understanding and manipulating quantum phenomena. Let's say you want to teleport a book from your living room to your bedroom. You don't want to just move the physical book, you want to send the information contained within it. Now imagine doing that with every atom in your body. To teleport a person, you'd need to record the precise state of every single atom in their body, which is a mind-boggling amount of information. Even if we could solve the information paradox, there's still the issue of energy. Teleportation, even at the quantum level, requires a tremendous amount of energy. To teleport an object, you'd essentially be converting its mass into energy, transmitting that energy to another location, and then converting it back into mass. The amount of energy required to do this for even a small object would be astronomical. Scientists are exploring various ways to overcome these energy barriers, but for now, the energy requirements of teleportation remain a formidable challenge. Teleportation isn't just about moving matter from one place to another, it's about preserving the intricate web of life. The human body is a complex and delicate system, and even the slightest disruption can have cascading effects. Imagine teleporting a human being. You'd need to ensure that every cell, every organ, every neuron is reassembled in its exact original state. The biological challenges of teleportation are immense, and they go far beyond our current understanding of biology and medicine. A wrench in the works? Imagine trying to hit a moving target while wearing a blindfold. The uncertainty principle states that there are certain pairs of properties, like position and momentum, that cannot be known with perfect accuracy at the same time. To teleport an object, you'd need to know the exact position and momentum of every single atom in that object. But the uncertainty principle tells us that this is impossible. This fundamental limit on our ability to measure quantum properties throws a wrench in the works of teleportation. The prospect of teleportation raises a host of ethical considerations that extend far beyond the realm of science. If we could instantly transport ourselves across vast distances, it would fundamentally alter our relationship with space, time, and each other. While this could foster global interconnectedness and cultural exchange, it also raises concerns about security, privacy, and the potential for misuse. These are just some of the ethical dilemmas we must grapple with as we continue to explore the possibilities of teleportation. Despite the formidable challenges, the quest to unravel the mysteries of teleportation continues. Scientists around the world are exploring new avenues of research, pushing the boundaries of our understanding of quantum mechanics, space-time, and the very nature of reality. While we may not be stepping into teleportation booths anytime soon, the insights gained from this research are already having a profound impact on other fields. The pursuit of teleportation is a testament to the boundless potential of human ingenuity and our insatiable curiosity to explore the unknown. Imagine two particles linked in a way that defies our everyday experience. They are connected, entangled, so that no matter how far apart they are, even if they're on opposite sides of the universe, they share the same fate. If you change the state of one particle, the other instantly mirrors that change, as if by magic. This spooky action at a distance, as Einstein famously called it, is the mind-boggling phenomenon of quantum entanglement. When two particles become entangled, their fates become intertwined. They are no longer independent entities, but rather part of a single, unified system. Entanglement is one of the most bizarre and counterintuitive predictions of quantum mechanics, but it has been experimentally confirmed time and again. Quantum teleportation, the closest we've come to real-life teleportation, isn't about beaming Captain Kirk across the galaxy, at least not yet. Instead, it involves transferring quantum information, the properties of particles, from one location to another without physically moving the particle itself. Think of it like sending a blueprint of an object rather than the object itself. The process relies on the spooky action of entanglement. Scientists start with two entangled particles, let's call them Alice and Bob. They separate Alice and Bob, sending one to a distant location. Quantum teleportation has been experimentally demonstrated with photons, electrons, and even atoms, teleporting information over increasingly large distances. Imagine a tunnel through the very fabric of space-time, a shortcut that connects two distant points in the universe. This is the mind-bending concept of a wormhole, a theoretical portal that could allow for faster-than-light travel, or even time travel. Wormholes arise from Einstein's theory of general relativity, which describes gravity as the curvature of space-time. Traveling through a wormhole would be like taking a shortcut through the universe. However, there are significant challenges associated with wormholes. They are thought to be incredibly unstable, prone to collapsing before anything could travel through them. Exotic matter, a hypothetical substance with bizarre properties not found in any known particle, holds the key to unlocking the potential of wormholes and other mind-bending concepts in physics. Imagine a substance that, instead of being pulled by gravity, is actually pushed away, a substance with negative mass. This strange stuff, if it exists, would violate our everyday experience and some of the fundamental laws of physics as we know them. Despite numerous attempts, scientists have yet to find any evidence of exotic matter. If found, it could unlock possibilities beyond our wildest imaginations, potentially paving the way for interstellar travel, time travel, and other mind-boggling technologies. Teleportation raises ethical and societal questions beyond science fiction. It would fundamentally alter our relationship with space, time, and each other. Imagine a world without borders, fostering global interconnectedness. But it also raises concerns about security, privacy, and misuse. How would we control access to teleportation technology? What would prevent criminals from exploiting it? The instantaneous nature could have profound psychological effects. We must engage in thoughtful discussions about its implications. The concept of teleportation, once relegated to the pages of science fiction, is now a subject of serious scientific inquiry. While we may not be stepping into teleportation booths anytime soon, the strides made in quantum teleportation and our growing understanding of space-time suggest that teleportation, in some form, may not be as far-fetched as it once seemed. The challenges ahead are formidable. We need to unravel the mysteries of quantum entanglement, harness the power of exotic matter, and perhaps even rethink our understanding of the very fabric of reality. It will require a concerted effort from brilliant minds across disciplines, pushing the boundaries of human knowledge and ingenuity. The pursuit of teleportation is not just about finding a faster way to travel, it's about exploring the ultimate limits of what's possible. It's a testament to our insatiable curiosity, our desire to understand the universe and our place within it. Whether teleportation remains in the realm of science fiction or becomes a reality, the journey itself is already transforming our world, leading to groundbreaking discoveries and technological advancements that will shape the future of humanity. For decades, teleportation has been the stuff of science fiction, a thought-provoking concept confined to the realms of fantasy and imagination. But in recent years, something extraordinary has happened. Scientists have made groundbreaking strides in teleportation technology, turning what was once thought impossible into a tangible reality. We're not talking about beaming up to spaceships just yet, but the advancements in quantum teleportation are nothing short of astonishing. Remember those entangled particles we talked about, the ones linked in a way that defies distance? Well, scientists have figured out how to use this spooky connection to transfer information, and even the properties of particles from one location to another without physically moving the particle itself. It's like sending a blueprint of an object rather than the object itself. You're not moving the physical matter, but you are transferring the information that defines it. This information can then be used to recreate an exact replica of the original, albeit using different particles. These breakthroughs are not just theoretical curiosities, they represent a fundamental shift in our understanding of the universe and our ability to manipulate it. The implications of this technology are far-reaching, with the potential to revolutionize fields like computing, communication, and even medicine. In 2017, a team of Chinese scientists achieved a remarkable feat. They successfully teleported a photon, a particle of light, from Earth to a satellite orbiting over 870 miles above the surface. This groundbreaking experiment, hailed as a major milestone in quantum communication, proved that teleportation is not just possible in the lab, but can also be achieved over vast distances. The experiment involved creating a pair of entangled photons on the ground and beaming one of them up to the satellite. By making specific measurements on the remaining photon on Earth, the scientists were able to instantly transfer the state of that photon to the one on the satellite, effectively teleporting it across hundreds of miles. This achievement has paved the way for the development of ultra-secure communication networks impossible to hack because they rely on the fundamental laws of physics. Imagine a world where sensitive information like financial transactions or military secrets could be transmitted instantaneously and with absolute security, thanks to the power of teleportation. And it's not just photons that can be teleported. Scientists have also successfully teleported the properties of atoms and even small molecules, demonstrating the versatility of this technology and its potential applications in fields like material science and quantum computing. While the idea of teleporting humans or objects remains firmly in the realm of science fiction, the breakthroughs in quantum teleportation are already having a tangible impact on our world, paving the way for a new era of technological innovation. One of the most promising applications of teleportation technology is in the field of quantum computing. Quantum computers, which harness the bizarre properties of quantum mechanics to perform calculations far beyond the capabilities of classical computers, rely on the ability to manipulate and transfer quantum information with extreme precision. Quantum teleportation provides a way to transfer quantum information between different parts of a quantum computer, or even between different quantum computers located far apart, without losing the fragile quantum state of the information being transferred. This could lead to the development of powerful quantum computers capable of solving some of the world's most pressing problems, from developing new drugs and materials to modeling complex systems like climate change and the human brain. Imagine a network so secure, so fast, and so powerful that it could revolutionize the way we communicate, share information, and even think. This is the promise of the quantum internet, a network built on the principles of quantum mechanics, where information is transmitted not through classical bits, but through entangled particles. The quantum internet would not replace the classical internet as we know it, but rather complement and enhance it, providing a secure and powerful platform for specific applications that require the unique capabilities of quantum mechanics. Quantum teleportation would play a crucial role in the development of the quantum internet, enabling the transfer of quantum information between different nodes in the network with unprecedented speed and security. This could lead to the creation of unhackable communication channels, ultra-precise sensors, and even distributed quantum computers that could work together to tackle complex problems that are currently intractable. The advancements in teleportation technology are not just a testament to human ingenuity and our insatiable curiosity to explore the unknown, but also a harbinger of a future where the line between science fiction and reality continues to blur. While the teleportation of humans or objects may remain a distant dream for now, the implications of these breakthroughs are far-reaching, with the potential to revolutionize fields like computing, communication, medicine, and even our understanding of the universe itself. As we continue to unravel the mysteries of quantum mechanics and space-time, who knows what other mind-boggling technologies await us on the horizon? One thing is certain, the future of teleportation is full of possibilities and the journey has just begun. The journey into the world of teleportation has taken us from science fiction to cutting-edge laboratories. Advancements in quantum teleportation are redefining the boundaries of possibility. Successful teleportation of particles signifies a paradigm shift in our understanding. Quantum teleportation allows instantaneous transfer of information, defying distance. Imagine a world with instantaneous secure communication and rapid calculations. However, teleporting larger objects, especially humans, presents significant challenges. The pursuit of teleportation is a testament to the indomitable spirit of human curiosity, our relentless drive to explore the unknown and push the boundaries of what's possible. It's a journey that has already yielded incredible discoveries and technological advancements with the promise of even more extraordinary breakthroughs on the horizon. Where will this incredible journey take us next? Will we one day be able to teleport ourselves across vast distances, exploring the cosmos and unlocking the secrets of the universe? Or will teleportation forever remain a tantalizing dream, a testament to the boundless possibilities that lie just beyond our grasp? Only time will tell what the future holds for teleportation. But one thing is certain, the quest to unravel its mysteries will continue to inspire generations of scientists, dreamers, and explorers, pushing the boundaries of human knowledge and shaping the destiny of our species. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment. What are your thoughts on these new breakthroughs in teleportation technology?